On This Week in Enterprise Tech, this is not the bandwidth you're looking for. The cloud comes crashing down, and SSDs are better than bacon. Quiet on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CACHEFLY.com.
This is Twiet. This Week in Enterprise Tech, Episode 32, recorded March 11th, 2013. SSD is better than bacon. This episode of Twiet is brought to you by Rackspace, the open cloud company. At Rackspace, build what you want, where you want, and how you want it. All backed by their world-renowned fanatical support. Try it today. Download the open cloud at rackspace.com/open. And by RingCentral. We do everything in the cloud. That's why I love my cloud-based phone system by RingCentral. Zero startup costs, and RingCentral is $20 per month per user. Try it now with a 30-day risk-free trial and buy one desk phone and get a second phone free up to 20 phones. Call 800-543-9980 or visit ringcentral.com and use our promo code TWIT. And by GoToMeeting with HD Faces by Citrix, the powerfully simple way to meet and collaborate with colleagues and clients from anywhere. You can share the same screen and see each other face-to-face with HD video conferencing, even from an iPad. Sign up for your 30-day free trial today. Visit GoToMeeting.com, click on the Try It Free button, and use promo code ENTERPRISE. Welcome to Twiet, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballas, the Digital Jesuit, your guide to all things in the enterprise. And I'm joined, as always, by an excellent panel, starting with Cheebert. That's right, the man from the hollowed-out volcano in Hawaii, the geek in paradise, the evangelist for thin links. Cheebert, how are things in Honolulu?
Actually, it's a gorgeous day. If it wasn't for all the fog, it looks like Los Angeles with a stage 3 smog alert. But, you know, how do you cite a volcano for pollution?
That's right. For those who have never lived on the islands, can you explain to them what VOG is?
It is a mixture of sulfur dioxide, volcanic ash, and all kinds of other weird and wonderful things that the ash is so fine in the air that it looks like you're covered with clouds. But
yes.
Everything's gray.
Yes. I always love that kind of dust that if you try to brush it off your sunglasses, you will scratch the living heck out of them. But let's go from VOG to pure sunshine. That's right. Curtis Franklin down in Florida. Curtis, how are things on the Enterprise East Coast?
I'm happy to report that things are warm, sunny, and completely volcano-free here in Florida. All of the gators we've got would be awfully confused by VOG, I think. But things are well here in Florida. The Sunshine State is living up to its name, and we're looking forward to another great week here in the swamp.
And rounding out our merry-go-round in locations of the United States, we've got coming back Alan Malventano from PC Perspective. He's our storage expert, our storage guru. And, well, how are things in South by South Weird country?
Yeah, actually, I wanted to go to South by Southwest and could not. Heard some cool stuff happen there. But, yeah, it's all right. It's like 60s today-ish.
Ish. I like
it
ish.
rained yesterday, which is rare for Texas. It likes to go months at a time without raining here.
Well, it's just part of the charm. Now, let's get straight to it with our Enterprise Bite. The first story is, well, it's one that I'm pretty sure a lot of the consumers who are listening to the show are going to find a little incredible, and that is Irene Estevez, who is the Chief Technical Officer of Time Warner, on Google's 1 gigabit service in Kansas City has said, "We're in the business of delivering what consumers want, and to stay a little ahead of what we think they will want. We don't see the need to deliver that 1 gigabit per second to consumers." She's basically saying, look, we've done the studies and nobody wants faster internet. Let me start with you, Cheebert. This sounds like the desperate cry of a CTO trying to justify a failed business plan. What's your take?
What is she smoking, and can I have some?
Well, you are in Hawaii, so.
Yeah, well, I tell you, $75 a month for gig Ethernet, especially if that's symmetrical, is worth it in spades. Currently, Oceanic Cablevision in Hawaii, if I want a 10 meg per second symmetrical, that's going to cost me $300 a month. And that only gives me 6 IP addresses for a commercial account. So $75 a month, symmetrical gig, yeah, I'd be all over that.
Right. Over to you, Curtis. A lot of people are going to ask, well, why are we covering this in an enterprise show? And I think what we've seen in Kansas City is that when you offer an incredible service like that, when you give them fiber to the house, when you give them 1 gigabit symmetrical up and down unlimited, it sparks innovation. We've already got business parks popping up around that Kansas City area that's already been rolled out. And it lets people do things that they weren't able to do in the previous telco model. Do you see something like this popping up in cities across America where you create sort of the high-tech area that invites people to come in and place their startup, place their new service, place their new business model?
Oh, I do think that it matters a great deal. We've seen it. Kansas City is the first really controlled study, if you will, but we have seen that the companies care about what sort of connectivity they can get. It's important to note that the cable companies recognize this. That's why they have pushed a lot of state legislatures, 20 of them so far, to pass legislation that says that if anyone offers even the slowest broadband, that a community can't come in and offer truly high-speed broadband in competition. They realize that the only way they win and make money in a lot of cases is by being the only game in town. Now, I haven't looked deeply into what the good folks over at Comcast tested, or at, Time Warner tested. But my suspicion is that someone in their marketing group went out to customers and said, hey, if we offered a gigabit per second Ethernet and charged you $400 a month for your house, would you pay it? And most people said, why no? To which the marketing department comes back and says, customers don't want gig service. The telephone company proved through their utterly failed rollout of residential ISDN that even with a decent idea, it's possible to misprice it so egregiously that consumers won't buy it. I fear that's what the cable companies are going to do with gig Ethernet to the home.
Right. I want to touch on that story you mentioned where the telcos have been pushing to say, well, if we deliver at least 64K in an area, it has broadband. By definition, it's broadband, and therefore there's no need to allow any further competition. Alan, do you think the perception of what broadband is has changed a lot in the last, let's just say, 3 years?
Absolutely, yeah. Actually, in San Antonio, the service that just got rolled out was, well, seems pale in comparison to what you guys are discussing, but 50 megabit for $100 a month. But it's asymmetrical. It's only 5 meg up. But 50 megabit down is pretty, crazy fast considering what people are used to seeing in, just any given city, mostly.
Right, right. Now, there is an aspect to the story that, we have to bring up, and that is there are many people who are saying that this is not going to be a Google commercial product, even though Google insists that it will be. They're saying that Google has created this as a PR stunt or as a disruptive service, a way to sort of kick the telcos in the butt so that they develop the networks that Google doesn't want to have to develop. Chibert, let me throw this over to you. Kansas City was picked because it was really close to one of Google's colos, and it was relatively cheap and inexpensive for them to run fiber down into part of Kansas City and get everyone fibered up. But there are a lot of people who are saying this wouldn't work in San Francisco. It wouldn't work in Austin. It wouldn't work in New York because of the geographical distances to major Google colos. Do you see this as more of a sustainable business practice or a PR stunt, or maybe somewhere in between?
Actually, I'd say somewhere in between. Actually, it's not so much, well, look, the proximity to the colo is a pretty big deal. However, the number one reason why Kansas City got chosen, and I'm hearing about this from actual carriers, is because Kansas City, the metropolitan area, controls what goes onto the poles. You don't have to negotiate with a dozen different corporations on pole space. You don't have to negotiate, when you change carriers in between, say, even city blocks. Because Google was able to negotiate with one organization and get it up on the poles quickly and easily with very little political shenanigans, Kansas City had a big win there. We actually had an unconference a couple weekends ago, and that was one of the big topics, why Hawaii was such an utter failure for big gig, things like that.
Yeah. Let me go back to you, Curtis. When we're talking about broadband rollout and when we're talking about getting broadband to everyone in the country, what do you think has been the typical response of an embedded telco, an incumbent telco? We already spoke about how they've been trying to deny competition, but, we shouldn't think of them as evil men twirling their mustaches in the background. What are the actual network-related concerns that they have about giving everyone higher bandwidth?
Issues are slightly different when you talk about telcos and cable companies. In telcos, the issue in most cases is simply the fact that they're going over telephone cables. They're going over copper. If they want to get much beyond, ADSL, then they really have to start looking at something like FiOS, fiber to the home. And that becomes an enormous physical plant upgrade. Now, cable companies, it's different. The coax that cable companies pull can support very high bandwidth. With them, it tends to be issues of neighborhood. Again, we get back to two issues. One of them, and the one that is the controlling factor, is physical plant upgrades. In most of the country, the physical plant for telco is not greatly above where it was in the 1960s. And in too many cases, for cable companies, it's about where it was in 1990. In order to deliver both their regular service, whether it be voice communications or cable television, plus very high-speed internet, we're looking at some pretty substantial physical plant upgrades, and that requires an investment that they want to know can be paid back in a finite period of time. The pricing of that gets all kinds of weird, and I really think that's why we haven't seen greater rollout of all these.
All right. All right, I want to roll on to our second story, and that is about EA's disastrous release of SimCity. SimCity, one of the hottest selling titles of all time, one of the most played video games simulations of all time. Well, EA made a mess out of it. Basically, a combination of DRM and back-end server processing requirements made the experience of playing the game for millions of people an absolute horrible boondoggle. It got to the point where Amazon actually stopped selling the game because people were saying, look, I'm buying it and it doesn't work. Now, here's sort of the backstory. There were two things that were happening. The first is that EA has created SimCity to require a persistent internet connection for two reasons. One is DRM, for digital rights management, but more importantly, because a lot of the processing, a lot of the heavy lifting, like what happens to buildings, what happens to the cities as time progresses, it's actually done on a remote server. So in essence, what EA did was a huge experiment in cloud computing, and it has absolutely imploded. EA went out and they apologized, and there was a lot of bad PR over the weekend, but they've also even offered customers a free EA game. It's that bad. Chibert, I want to throw this to you first because this could be looked at as a great experiment of cloud services gone bad. What did EA do wrong here?
Yeah, this is my favorite soapbox. They did some testing. They would have been stupid not to do testing, but they didn't scale their testing up. Very, very few corporations now actually run the boxes to do the synthetic traffic. You could use something like WebRunner and LoadRunner and actually generate an amazing amount of synthetic traffic and find out just how much load balancing you need to do, figure out the rules on shedding load and moving load around. Very few companies are willing to take the investment to really and truly do enough synthetic load to simulate the anticipated load and then go beyond. everybody says, "Oh, we only need maybe about 100,000 users," but then all of a sudden they hit 250,000 and life goes down the tubes. Well, it's because of lack of imagination. People just don't test anymore.
Right. Curtis, by all accounts, this wasn't just a minor misunderstanding or misestimation of how popular the game was going to be or how many resources it was going to require. EA has said that they've increased their server capacity almost 1.5 times. They've over doubled what they had during the rollout, and people are still reporting outages. There is a suggestion that maybe the system that EA has chosen to do all the processing in the back end, in the cloud, just isn't scalable. That sounds like worst possible scenario, right? If you find out that just adding servers isn't going to fix the problem?
Oh, it is absolutely a worst case scenario when you have a solution that runs into some sort of natural limit, whether it be in the way it breaks up processing, the way it handles I/O, whatever, in such a way that, as you said, it just hits limits on scaling. Then you've got a huge problem, because that means you've got to go back and re-architect some central part of your overall system in order to make it work. This gets back to an issue that I've talked about with a lot of companies, and I see over and over again. Companies prepare for disasters. Companies prepare for failures. The hardest thing in the world to do is get a company to really prepare for success. We've seen this a lot of times. If you put out a marketing program and everybody responds, what happens? Well, in most cases, your system collapses under the weight. Why? Because we're used to thinking about failure and how to limit the damage from failure. We haven't really built a mindset that says we need to look and see what happens when we succeed beyond our wildest dreams. That happens to EA, and it's a real lesson for everyone else who's doing anything where success is at least something of an option.
Right. And I think for us in the enterprise, that's a real lesson for any rollout we might be doing of cloud services, which is, again, if you're going to design it to use cloud services, if you're going to design it so all the processing is done on the back end, you need to make sure that your process can scale up. It's not enough to say, well, we can add servers. You have to be asking the question, will additional capacity, additional CPUs, additional memory scale up my service delivery, or is it just going to bottleneck somewhere that is going to be difficult to fix? Alan, I want to throw this to you in a slightly different angle, and that is something that PC Perspective may be more familiar with, and that is the persistent connection. Yes, it was required for the back-end processing, but it was also required for DRM, and anyone who has played with DRM knows that this is one of those things that, well, we kind of laugh at, because DRM is a way to make sure that anyone illegally obtaining your service or your product will be able to get a better experience of it than someone who's using it legally. What do you see in EA's use of a always on connection, the need to always be connected in order to even open the game?
Yeah, it's actually, I can almost speak for the whole gang at PC Perspective. We just sort of shrug our shoulders and roll our eyes and just not buy those games, right? Or if we do, then whoever did, we sort of just chuckle at, because the darn thing won't work, right? Just like as evidenced during this launch. Although this game's a little bit of an oddball, because it's not just the DRM that required the persistent connection, right? It's like the game just wouldn't function. So, even if there was some way to illegally obtain this game, and chances are the game wouldn't work properly anyway, because it does need that connection to do part of the functionality of the game.
Right.
And that's actually sort of an argument some of us have been having, is like, does this thing really need to have cloud anything if you're only playing single player? I mean, I can get that, there's a possibility of linking up with other people later on once you've expanded your city or however the game works, but really, do you absolutely have to have it, all the time like that? And not only that, but speaking, I could put my Navy hat on now. Guys that are out at sea or deployed somewhere, they don't have internet connections, and they might also want to purchase these products, and they're not going to, because the darn thing won't work, right?
I can see it now. There's going to be a Seawolf submarine somewhere that needs to surface for a couple of hours because the crew just needs their SimCity fix.
Exactly.
I think it was put most succinctly in the chat room by Y Guy, who just put hashtag DRM sucks. It really just kind of sucks. Chibert, I want to give you the last word, specifically going back to the cloud computing component of this. We're going to see more and more of this, not just in video games, but in business applications that are taking advantage of grid processing, that are taking advantage of services offered by, say, NVIDIA or built up by Microsoft or Amazon. Can we expect to see some more of these high-profile failures in, say, the next 6 months? Chibert, you're muted.
I think we are going to start seeing that. Actually, one of the things that I'm actually really taking a look and holding my breath at is actually Google Glasses. Because Google Glasses is going to require an amazing amount of back-end computing to be able to do a lot of the recognition and things like that, voice recognition, the on-the-fly translation. I've been doing a lot of playing with Google Translate, and that requires an amazing amount of back end. So, yeah, sooner or later, the bottlenecks are going to start appearing, whether it's going to be in processing or whether it's going to be in bandwidth, getting that amount of information back to the data center. It's all going to be part of a learning process. I think we need to have a little bit of patience, but I think we also need to expect that the corporations that are rolling out these services need to start thinking strongly about testing, creating that synthetic traffic so that they can do what-if scenarios. That seems to be missing from a lot of product testing nowadays. Can you break it? Because if you can break it, you darn well know some hacker's going to manage to break it, either on purpose or by accident.
Right. Well, we're talking about the cloud because we know that the cloud is the future of enterprise. But you know what? Not all clouds are the same. Everyone talks about cloud computing, but there's public cloud, there's private cloud, there's proprietary cloud, there's open cloud. Some use proprietary technology, which makes it expensive, which can increase performance, something like EA SimCity. But on the other hand, if it's proprietary, it becomes more difficult to scale. What you want, and what I think we're looking for, is an open standard, a way to have open computing that scales well, that builds our business, and allows us to work the way that we want to work. That's why I am more than excited to welcome Rackspace to the hallowed halls of Twiet supporters. Rackspace is the open cloud company that co-founded OpenStack and now runs the world's largest open cloud. Open cloud means that you're not locked into a single provider. In other words, open cloud runs on different ISPs, on different providers, so you can move your services and your apps. You can move your apps, your code base, your websites between multiple OpenStack-based clouds, public or private, on-premise or hosted. You're never locked in, and that's always a good thing. Big business or small, public or private, services or data, Rackspace is the perfect solution for the Twiet crowd because they get the enterprise. Oh, here's a little challenge I want to give to you. If you're listening to me right now, I want you to help me welcome Rackspace to Twit. I want to show them that the Twiet Riot crowd gets them like they get us. I want you to send a tweet to Rackspace, thanking them for being part of This Week in Enterprise Tech. Tell them that the Twiet Riot is ready for the rack. And now here's the offer. Build what you want, where you want, and how you want, all backed by Rackspace's world-renowned fanatical support. Try it today. Download the open cloud at rackspace.com/open. That's rackspace.com/open. We thank Rackspace for their support of This Week in Enterprise Tech. Now let's get back to it. We've got another story here that outlines a possible threat, and that is the FCC outlawing cell boosters without the permission of the telcos. Now, Chibert, I want to give this to you because you brought this story to my attention. I want you to do the initial rundown.
Well, the whole concept of the cell booster is that you have really crappy service and you want something to just get you maybe 1 or 2 more bars so maybe you don't drop so often. Now, what's nice is some of the carriers are now providing either free or cheap cell boosters. T-Mobile's doing cell boosters. Now, it's different from a microcell, a femtocell, which is what AT&T is doing. And actually, T-Mobile does femtocells too, but only in Europe and under Deutsche Telekom. So the difference is a cell booster is strictly an amplifier. You stick an antenna up on your roof or someplace where you actually do have at least 1 bar, and then you go and lead the cable inside your facility, home or whatever, and an active component then takes that signal, amplifies it, and life is good. They come with anywhere from 1 or 2 cells all the way up to maybe a couple dozen cells capable. Now, the big problem with this is the carriers hate these because people never install them quite correctly. Sometimes people boost them up and they don't even need them. So what happens is you start getting this bleed over into other people's homes, and then if someone turns it off or moves it, all of a sudden now a whole bunch of support calls. A femtocell is different in that it actually rides over your internet and creates a really tiny cell site just in your home. So it's actually creating new signal rather than just boosting signal. Because remember, amplifiers, if they get a lot of noise, they also amplify the noise. Now, here's the issue that the FCC hates. They don't want all these microcells, all these blobs of RF moving around. They want to know where they are because then they're dealing with licensed radio spectrum, and having unlicensed facilities roaming around and changing the RF envelope means that if you're getting interference, the FCC has no way of figuring out what's going on. I'm not sure I like this, especially because this one particular stretch where I'm driving through a forest preserve every morning, Kurt knows, my cell phone will always drop out if it's raining when I get out of the mouth of this one particular tunnel. So I've actually put a cell booster in my car just so that it won't drop when I get out of this one particular tunnel. So is it good? Is it bad? Well, it's neither good nor bad. It's gray. If people start using them as they should, then the FCC probably wouldn't have had to go and be stupid about this. But now they're just doing a blanket, thou shalt not have a cell booster, and they're making it really difficult for the people that really and truly need it, like people that live on mountaintops or in deep valleys or what have you.
Yeah. Alan, have you used cell boosters, cell repeaters at all?
The closest I've seen to that was a femtocell. Actually, a friend of mine has in Charleston. But no, I've never seen or used an actual cell booster.
Right, right. Now, Curtis, I want to ask you about this because we don't like when the FCC comes in and tells us that we can't use technologies that we already have in our possession. But I can see why they're doing this, right? Because these companies have licensed the spectrum. They're actually paying for the privilege to be able to broadcast over it, to offer their service, which is, again, regardless of how you think about the telcos, it is a public good. And they're afraid that this technology, that these repeaters improperly used, could degrade the quality of service that they can actually deliver. And I've seen this. You can get really poorly constructed cell phone boosters, and if you put the antenna next to the transmitter, and it's not designed so that if they're too close, it'll shut itself down, it actually creates a nice little loop that is a nice little jamming box for cell signals. So it's, we don't like this, but it's an absolute necessity if we're going to continue expanding our wireless capabilities, right?
Oh, absolutely. And I think we have to keep in mind what the FCC cares about most, and that is getting everyone to play nicely together in what is, in fact, a finite sandbox. As you point out, it is all too easy to have signal bleed over to end up intentionally or unintentionally improving the signal for one person while degrading it for someone else. And by making sure that everyone who deploys something like this has the approval of some cell carrier, it minimizes all this. And this is also important from the FCC standpoint. If the cell company has approved it, that means that the onus for resolving any interference or signal degradation claims goes back to that cell company. That means that we now have someone to blame, someone to hold responsible when things go wrong, and that someone who is held responsible has a staff of engineers who can ideally solve the problem.
Right, right. And I should note that this is only referring to the licensed spectrum. So it does not affect Wi-Fi in the 2.4 and 5 gigahertz range. Those aren't the radios we're talking about. That's unlicensed spectrum. We're talking about the frequencies that have been purchased, leased, paid for by telcos so they can deliver their data services, their voice services. slightly different than what we're used to talking about, but it's still important. Let's go to the next story, which I also think is crazy, crazy important. A while back, we talked about this story about how the Department of Homeland Security had okayed, the watchdog for the DHS had okayed the seizure, the warrantless seizure of electronic devices at the U.S. border. Essentially, they came up with the idea that if you've encrypted something, or if you've tried to keep it away from their eyes, if you won't give them the password for it, that in itself becomes a suspicious activity, and without a warrant, they could claim your gear, your laptop, your iPad, your phone, your USB drive. Very contentious idea, and it did not sit well with the Ninth Circuit Court. The Ninth Circuit has curbed the DHS's power for warrantless searches and seizure. They essentially decided that the issue was not the location of the search, not the fact that it was at the border, but that the nature of a forensic search without suspicion would violate the Fourth Amendment. The court also noted that using encrypted data devices was in and of itself not suspicious activity. So just because you've encrypted the data that you have on a laptop, say going to China, because you didn't want anyone to pry into it, that doesn't mean that you are then subject to search. I want to go to you first, Curtis. This is something that a lot of enterprise travelers have run into in the last couple of years, and that is they needed to sort of balance their desire to have their data, their proprietary secrets, their company information kept secret, but at the same time not run afoul of the DHS when they came back into the country. This should be sort of a nice, warm, welcome response, yes?
Well, it certainly should be, and I want to preface all my remarks by saying that I am not a lawyer and I don't play one here on Twiat, but were I in corporate or enterprise IT and sending people out across the borders, I would be pleased about this. Now, I am fairly certain that DHS is going to appeal this. We haven't heard the last of this, but I think the Ninth Circuit has done something important in placing limitations on this. And I also like the basis of it by saying it doesn't have to do with the border. The location is irrelevant. It's the very notion that by having an encrypted file, you're doing something suspicious. It's sort of like saying that if you lock your front door, that means that the police have the right to come in, burst down the door, and check you out because, hey, if you weren't doing anything wrong, you wouldn't lock the door. Well, when we say it that way, it seems silly. The same thing is true about encrypted files. I like the basis on which they decided this, and I like the fact that they are protecting us from the, we'll give them the benefit of the doubt, well-meaning overreach of one department of the government.
I want to move this conversation to our representative from the Lone Star State. In the chat room, we've got Beatmaster who's saying encryption doesn't mean that you're a criminal, just that you're protecting yourself from criminals. We've got Web 7419 mirroring Curtis's remarks saying, well, locks are suspicious. You, sir, living in the great state of Texas, what do you think about someone coming to you and saying, well, you know, I see that you got a lock on that box there, so therefore that's suspicious. Or I see that you've encrypted your data, and so therefore for the good of the country, I'm going to need a password from you.
So, yeah, I don't know what the electronic equivalent of pulling out a shotgun is, but that's what would happen in Texas if you tried to use the front door being locked analogy there. Yeah, I don't know. I encrypt all of my stuff, and it's not because it's illegal. It's just because I don't want... If I lose the device, if I'm traveling, especially when I'm traveling, right? If I lose that device, I just don't want anybody to just grab the thing and just go through everything that's on there. It's my data. It's not for whoever happens to come across, you know, the device. So, right. Yeah, that should not make it so that, you know, anyone is just, oh, yeah, you're a suspicious person now because you effectively put a lock on your door. Right.
Cheebert, let me throw this over to you. Of course, being in the enterprise, being an IT person, in fact, even using a computer and having a relative amount of knowledge that encryption isn't an evil thing, we don't think that encryption should be in and of itself a reason to look through your personal information. But an argument can be made on the DHS side, which is, look, we're losing the battle here. People are coming in. We know people are coming in with data that could help us solve crimes, that could help us prevent attacks on theoretical situation, blah, 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 blah. And if you don't give us some tools so that we can bypass this encryption, well, we're never going to be able to catch up. What's your take on that? I mean, let me throw this to you as, are you for the terrorist or are you for the country?
Gee,
Wow.
thanks. You know, as an ex employee of the federal government, you know, I don't have a problem with a federal agent coming up to me and saying, we'd really like to look at this encrypted drive. Fine. But I want to be there because I don't want some ham-handed, you know, non-IT person accidentally deleting, say, source code or accidentally deleting that spreadsheet that has the projections for next year's sales. You know, I don't mind them looking. I do mind that a lot of these clowns don't have the training to not accidentally delete some really key information. I encrypt because I want to make sure my competitors don't get it. I encrypt certain types of email because I want to be able to send someone a temporary password. You know, there's a lot of really, really good reasons to encrypt. So yes, I am pro encryption. No, I am not pro being able to look without a warrant, but I am more than willing to let federal agents look if they only ask nicely. So yeah, I'd love to let them have the tools so they can, you know, drug lords can't have encrypted, you know, distribution lists and things like that for where they're going to sell their drugs. But I also want them to be reasonable about it.
Right. Curtis, there was one last tidbit that was buried within the decision, and that was the Ninth Circuit judges acknowledging another aspect to this whole problem, and that was, given that we use cloud services, cloud storage, given that a lot of us use VPNs, they said there was this sticky legal precedent that they didn't want to set, in which unlocking a laptop or unlocking a tablet could potentially unlock access to data all around the world in colos and stored on drives back in corporate networks. And they weren't ready to make a ruling on that. Essentially what they were saying is you cannot demand that someone unlock their laptop if unlocking their laptop is also going to unlock a data center filled with terabytes of proprietary information. I think that was a good get, but that's also something that I don't think we've explored much. Our laptops, if they've been set up to properly access our networks, are gateways into data that is not stored on the local device, right?
Oh, absolutely. You know, this is something that we've talked about fairly often on Twyat, the fact that so many of our devices are much more than their local computational devices. They're communication devices. They are, as you put it, windows into the enterprise data, which is probably stored somewhere else. I think this is interesting because, to me, the Ninth Circuit is looking at what has happened with physical searches. I know a number of people in law enforcement, and it's very frequent that you will have someone make, you know, for example, a traffic stop. They'll look in the window, and having made that traffic stop, they'll see something, and because of that, then they go searching somewhere else. And before you know it, they've done a complete search of the car, all based on something very small. And where would that lead if we allowed the same principle to be at work with these laptop or small mobile devices and corporate data? You really hate to use an overworked phrase, slippery slope, but that's precisely what it is. Once you start down this path, really, where does it end? How far down that corridor that comes when you open the unlocked door can you walk? That's what they didn't want to get into, and I think by saying just don't unlock the door, they at least kick that particular can down the road a bit.
Yeah. And as we know, here in the enterprise, we don't like legal fishing expeditions. But you know what we do like? We love the cloud. And that's why when we built the brick house and Leo decided everything should be in the cloud, we were absolutely thrilled when our IT guy, Russell, came up to us and said, hey, did you know that you don't have to have a PBX? He said, did you know you don't have to have all that clunky hardware in-house? Did you know that you could have all the goodness of a true PBX system, but store the service in the cloud? And that's why we love that we went with Ring Central. We love Ring Central because there are zero startup costs, because there is no PBX hardware to install or maintain, We love RingCentral because it allows us to easily customize all of our call handling. Our producers can get their voicemail and their emails, and we can get our fax messages on our smartphones or tablets. It's really that simple. You want PBX service, but you don't want the PBX maintenance and headaches that go along with it. Well, RingCentral has a system for you. Now, RingCentral offers all-inclusive pricing as low as $20 per month per user. You can start right now with a 30-day risk-free trial, and they have a special offer for my listeners. When you buy one desktop phone, you get a second phone free, up to 20 phones. So call this number, designated for my listeners, 800-543-9980. That's 800-543-9980. Again, one more time for good luck, 800-543-9980. Or you can go to ringcentral.com and use promo code TWIT. That's ringcentral.com, promo code TWIT. Find out what RingCentral can do for you. And we thank RingCentral for their support of This Week in Enterprise Tech. Now let's get to the heart of the episode. We are talking a few things storage. Now, the first story I want to bring to mind is, how Seagate is ceasing production of 7200 RPM 2.5-inch drives. Drives sort of like, well, this. Now, it doesn't mean that Seagate's getting out of the hard drive business. It just means that they've recognized that there's more of a move towards solid-state drives, solid-state hybrid drives, or high-capacity, low RPM drives, 5400 RPM drives. Alan, I want to throw this over to you because I got a briefing from Seagate at CES, and they were trying to explain to me how oral densities have increased to the point that you actually can lose performance if you spin the platter much faster than 5400 RPM. How is that true?
Usually it has to do with heat, just because the drive runs at a higher temperature, and some of these drives are designed to scale back a little bit on the throughput if the head and the disk platter is just running at a higher temperature than normal. And especially in the cramped space of a laptop, and especially nowadays, like with everything moving towards ultrabooks and really small form factor, sizes, and everything's just really compact and sort of jammed in there. It's difficult to get a lot of airflow across that thing when it's literally just right between both halves of the device.
Right. Cheebert, you've been building servers for as long as I've known you, and you mentioned in the pre-show that a lot of servers used to use 10,000 and 15,000 RPM hard drives to get that little bit of extra performance that you wanted for the massive I/O of a server. We don't see much of that anymore, right? I mean, and again, partially because of what Alan mentioned, the heat issues, but also we just don't need the platters to spin that quickly.
When you start talking about what Seagate's done with their hybrid drives, excuse me, it's all about throughput, really and truly. How fast can I move data in and off that drive? And if someone comes up with a better technology, like, I'd love what Seagate's done with the hybrids. Seagate no longer needs to spin the disk at 7200 plus RPM. They can spin it at 5400 RPM, which is inherently a more stable design because you have less Coriolis forces dealing with head alignment and things like that. You've got less problems with the Bernoulli effect, with the heads floating above the platters and things like that. It's just a better design because there's less things that can go wrong. So, yeah, I'm starting to see a lot more people putting SSDs in, but it's only in, say, like swap drives or primary drives or things that have data that's really important, but they've been using the spinning drives for everything else because they're so much cheaper. Well, I think our friends at Seagate have a winning combination, and I'm really looking forward to seeing their new line of hybrids that are 3.5-inch form factor. And I'm thinking, man, that would be pretty awesome in some of my servers.
Hint, hint, hint. Curtis, let me go over to you because you've got your finger on the pulse of the typical enterprise user. Is that finger on a high RPM hard drive, or has high performance enterprise pretty much moved all over to solid state?
Well, I think that the high performance is in fact moving to solid state. What we're seeing more and more is the concept of tiered storage, where you have your very important, very hot data, often transactional data, Beyond that, you have your longer term, not as hot, often this data that's used for analytics purposes. Then you have backup stuff, where at one time you would use different categories of spinning disks for your first and second tiers. Now what you're seeing is more and more companies putting transactional material onto the SSDs. Now, the spinning disks aren't going to go away. Why? Because as Chibert said, they're cheap, and they're going to stay cheaper than SSDs. The fact is, though, that as SSDs get cheaper, the tier that can be used with those is growing. And so we're seeing a lot more companies putting those in all of their transactional databases. And I think that's going to grow. And it just makes a lot more sense. You don't have the environmental issues, the reliability issues that a lot of people were questioning with SSDs in terms of longevity are being answered by new architectures. And so when I talk to the big enterprise buyers, SSDs are a much more important part of their overall storage plans.
Yeah. What I like about this is, well, Seagate just purchased the old Solera plant, which had a super high-profile, multi-billion-dollar failure. The old Solera plant in Fremont, California, and they're going to be turning it into a huge R&D facility. And I think there's no question that it's going to be R&Ding the next generation of Seagate hybrid drives and the next generation of Seagate SSD drives, which brings me to the matter that we really want to talk about, and that is SSDs in the enterprise. That's why we brought in our storage expert, Mr. Alan Malventano from PC Perspective. Alan, you did a really good article that a lot of people just thought went way over their heads, that tried to, well, tried to explain the problem that people think SSDs have with durability. Can you tell me, why is it that people still associate SSDs with higher failure rates than, say, rotating drives?
I hate to say this, but there was one particular controller that came out, and now let me caveat this. There have been bad batches of spinning disks in the past from companies that have given various companies a bad name. There was, I think it was actually Seagate, of all companies, that had an issue with the firmware on one of their drives, where drives would just disappear, and it was really bad if you ran them in a RAID. But again, that was a long time ago, and it was corrected. Even Western Digital had an issue with back when hard drives were about 400 gig in capacity, where drives are just running too hot for their specific design. And they just had a bad batch of those. I actually got burned on that personally. I had like several drives out of a RAID all fail at the same time, just pure coincidence. So
that's why I only purchased Hitachi drives. I had great experiences with Hitachi drives. Death Star.
Exactly.
I'm sorry, continue.
With the Death Star. Yes. So this happens with everything, right? So for SSDs, we had something similar happen in the early SandForce controllers. And there was just some kind of weird bug, and it would cause the things to just literally brick. They would just, some weird piece of metadata wouldn't be written correctly, and if you started it up in just the right kind of when the planets were aligned a certain way, this controller would just decide to fail. Really bad, right? Because the typical way that SSDs are supposed to fail when they do is due to being completely worn out. In other words, you've written to the flash memory as many times over and over again as it was able to handle properly, and then it just couldn't take that anymore. And then the way that it's supposed to fail when that does happen is it's supposed to be graceful. In other words, all your data is supposed to still be there. You can still access it. You just can't write to the drive anymore. That's supposed to be the limit. However, when the controller itself fails, or if there's some kind of weird issue with the firmware that controller is operating under, then the entire drive goes away. All the data behind that controller is just inaccessible. So those sorts of things happened early on in like, I guess you could say relatively early on in SSD, in the SSD landscape, if you will. A lot of that stuff has been corrected. Been lessons learned. Companies have learned from those mistakes. They've moved on. You see a lot less of that these days, fortunately.
All right. Let me go over to Curtis. Curtis, as you mentioned, most enterprises are going to flash-based storage, especially for the super high input-output throughputs. But there again, I've heard murmurings on enterprise boards, and when I've gone to enterprise conferences, of people saying, well, SSDs are fast, and I like the fast that they're fast, but I'm still going to stick with my rotating media because it's more durable, or it will last longer. It's got more reliability. Is that a common viewpoint in the enterprise community?
Well, I think it's a common question in the enterprise community. What you end up with are people who got their concept of SSD longevity established 15 years ago, and it's never been reset. Now, SSDs are increasing in their longevity. I think a lot of them now have a rated life cycle of at least 100,000 writes, which, if you think about it, is an awful lot. And on top of that, when you look at the controllers that many of the companies are putting together with their SSD systems, they have the ability to automatically detect a failure in a bit and remap that data to a failback SSD so that you don't lose anything. Is it an issue? Probably. But the fact is that the gap between SSD reliability and spinning magnetic media reliability is narrowing considerably. And when you do the math, for most companies, the system within which the device sits will hit end of life and be surplused out long before it hits the rated number of write cycles. So I think realistically, this is something that should be a minuscule concern for most individuals in most companies.
Yeah. Let me throw it over to Chibert, because Chibert, you're actually building NOCs. You're actually building these servers. Would you consider building a high-performance server today with just rotating media?
It's not so much now a technology issue as a money issue. If I can afford it, I'm putting SSDs in, at least as my primary drives, so that my boot cycle is much faster, my OS load is much faster, the swap is faster, and so forth. Realistically, in my mind, if I could afford to go all solid state, I think I probably would. And the servers I'm currently building, sitting on my workbench now, I want to go all solid state because those are going to be shipped around the world, actually, as I start doing more and more trade shows for ThinLinks.
Right. All right, Alan, let's get back to you, because I lean on you for the true storage expertise. I've heard a lot of terms thrown around when we're dealing with SSDs. It's people who are convinced that you need SLC. There are others who are saying, no, MLC is just fine. And they're talking about the reliability of the drive. But when we talk about what wears down an SSD, well, what is that? Why do SSDs wear down? Why are people concerned with the reliability of SSDs? What is it? What's the mechanism that makes it that SSDs only have a certain number of reads and writes before they're no longer useful?
First of all, it's not the number of reads. So we'll just clear that up right now.
There we go. That's a good thing.
Right? If you were to write a whole bunch of data to an SSD when you first bought it, you could read it as many times as you like. It's still going to be there. You don't wear anything out by doing that. It's the writes that do the wear to the flash memory. And the flash memory for SLC or MLC is simply down to how many cycles can you write to that memory before it loses its integrity. It's not so much that just all of a sudden, MLC is typically rated for either 10,000 or 5,000 cycles, just depending on how much of a die shrink that process has been used to make the flash memory. It's not like you hit that 5,000 mark and then all of a sudden, boom, it's done. It just doesn't work anymore. It's not like that. It's that the more you wear it out, the more you write to it, it actually wears out the cell that holds the charge, which is actually what's storing the bits. And it actually breaks down the insulation around that, which limits its ability to store the bits, first of all. It also affects how long it can store them. So if you have an SSD that's near its end of life, what a lot of people don't realize is it's not necessarily going to store that data for as long reliably versus when it was brand new. So don't go thinking you can just put it on a shelf, for 5 years after it has reached its end of life and expect to be able to read all that back later. It's probably not going to work.
Right.
Yeah.
I've heard things when dealing with SSDs like trim, which is wear leveling, to make sure that no particular cell gets worked over more than any other. Essentially, it distributes the load among the entire available cells within the SSD. But I think the question still stands, which is what factors determine how quickly an SSD will wear? I've heard some people have their own pet theories about, well, you should turn off this or turn off that service because it writes very quickly. You should turn off indexing. You should turn off page filing. But I never really hear a consensus on what are the things that you should do to prolong the life of your SSD.
Okay, so some of those things that they recommend you to turn off, like prefetching and different Windows features and such, just aren't necessary to accelerate the system when the operating system is installed on an SSD. In other words, it's able to access that stuff so quickly with the improved speed of the solid state drive that you don't need these extra features. And that's very much true. And to some extent, it limits how much extra wear the SSD sees because those extra features are doing some writing to the drive. It's probably not significant compared to the actual use, like the actual using the computer sort of stuff. The things that will wear it out, it all boils down to simply how much you write and the method by which you write. In other words, if you're doing a bunch of very small, randomly distributed writes to the device, that's going to wear it out much, much faster than if you were writing just large bulk, like you were basically just sticking a bunch of large movie files on the drive, for example.
Right.
So the SSDs like to write large things, large files onto it. You know, that does the least amount of wear respective to what you're doing. The reason for this is that think back to old CDRWs. It's probably the easiest way or easiest comparison we can do here. For a CDRW, you were able to add little by little to the disk. And then once it was full, you had no choice but to read the whole thing back into your system and then basically clean it, right? Remember that old thing? You had to tell it to erase the whole disk. And then even if you wanted to just change one file, if you didn't have enough room to do that anymore, you had to do this whole long convoluted procedure just to change that bit of data. And by doing that, you were wiping out the entire disk and starting over. And you can only do that a certain number of times with the CDRW before that media would start to burn out. Same thing applies to flash memory, except in this case, it's what's called a block versus a page. Pages are usually like 2 or 4 kilobytes. Blocks are like 1 or 2 megabytes. And the only method of erasure and rewriting of flash memory is to erase the entire block. So all of those pages, whatever happens to be there, has to be moved out somewhere else, temporary space, whatnot, memory. And then the whole block has to be erased. That erase procedure is what counts as one wear cycle on the memory.
Right.
So if you were writing nothing but 1 or 2 megabyte files to an SSD, chances are you're just wiping out just one block just to store that 1 or 2 meg. There, you only did that much wear. If you're writing a bunch of really small things, every 4 kilobytes that you write to it, if the drive is completely full, it's going to have to blow away an entire 1 or 2 meg chunk worth of flash memory. So you've basically written that much. Not 4K, you wrote like a couple of meg. Now, where trim comes into play with this is not necessarily to affect wear leveling, because wear leveling is something that the flash memory controller does in the background and redistributes which blocks are being erased and when. Trim actually is the operating system's way of telling the SSD, hey, I've deleted these files. I don't care about this 20 gigabyte span anymore. So the next time I go to write a 4 kilobyte file to the center of that, you don't have to go through all that large process to save what else was there out of that couple of meg. You can just discard it. So in one way, it's a method of speeding up that process of writing a small file later to a space where you previously deleted those files. And it also does affect how much wear you put on the drive, because now it's not juggling around as much data to write over places that were previously cleared out.
So what you're saying is that the best possible thing you can do for your flash drives is to run disk defragmenter every other day.
Oh my goodness.
Okay, no,
That
no,
is-
no.
yes.
I don't want to get into that. But I do want to do is I want to bring this back into the enterprise arena because we've got a little demonstration here. We've got a Samsung 840. This is a nice drive. This is not the Pro version, so it's a little less expensive version. Fast performance, decent price, built on Samsung's proven track record of excellence. On this end, we've got a Kingston. This is a SSD Now 100E. It's the enterprise edition of their products. This is a slightly lower capacity than the Samsung. This has just about the same specs. If you look at the data sheet, the performance is pretty much the same. And yet the enterprise drive here can cost 2, 3, 4 times as much as the consumer level drive. What's the difference between these two? So if let's put this in the brass tacks. If I'm building a server, why would I want to use an enterprise SSD rather than the consumer level SSD?
Okay, so the big difference between enterprise versus consumer, and I'm going to speak kind of generally here because I'm going to try to group all of the enterprise versus all of the consumer. Enterprise drives will tend to have, first of all, higher grade flash memory. So when flash memory is binned, in other words, there's certain grades of it. There's the really low grade stuff that'll go into like your cell phones or your really small memory cards, like those SD cards and whatnot. It's just stuff that's going to store stuff, not a whole bunch of, not really getting that beat up, not being used as a solid state drive, which is arguably much more wear. So the higher grade memory goes into SSDs first of all, and then the even higher grade, basically the top grade, goes into enterprise class SSDs. So you're talking the flash memory that's rated for that much longer. As an example, Intel even has a thing where they call it, what is it, the eMMC or enterprise grade MLC, right? It's basically just the same stuff that's in the consumer grade drive, just a better binning process, higher quality, goes into the enterprise, and they're able to rate it for more writes than they can for just the consumer stuff.
Right.
Also, enterprise drives have a bunch of tricks. And if you were to open that drive there, if you were brave enough, you would notice that there's a bunch of capacitors along the PCB. And just to show some examples, like, for example, here's an Intel enterprise grade drive, and those little yellow squares on there, those are solid-state capacitors added to the drive. And then there's even another one where they went old school, and they have the old little can-style capacitors sitting on the edge there. What they do this for is more robustness in the case of power loss as writes are going on. So if you were designing a consumer SSD, you're not going to expect that consumer to be in the middle of a bunch of really intensive stuff as the power goes out. Like, it's not
there won't be a lot
vital.
of mission critical I/O on a consumer drive that could potentially bring down a company should they lose power at any given time.
Exactly. And the kinds of things we're talking about is if you were in the middle of writing a lot of bulk data to the SSD, chances are some of that wouldn't make it to the actual memory and be saved on a consumer drive. The enterprise drives try to catch as much of that as possible, and whatever is in its buffer, basically, whatever it's about to do, whatever it's received from its host, from its server, in order to be written, that's going to be written. There's enough capacitance, enough residual charge that are left over for it to finish all those tasks. And I realize when power does go out, you're still going to lose some things, right? There was still some, you know, if the server was only halfway done sending the file to the SSD, it does not have ESP, so it could figure out what the other half of that file was, right? You're still going to lose something. But the idea is to minimize that as much as possible for those kind of situations, and that's why they make those a little bit more robust. Also, you're able to get some more performance out of an SSD, enterprise versus consumer, by having that capacitance, that extra charge there, because the consumer SSD has to, every single transaction, it has to update its own internal databases of where it has put things. In other words, your transactional database for wear leveling. Whereas the enterprise drive can do some other things quicker because it doesn't need to save all that stuff every single instance of what's happening, right? So it can sort of do some effective buffering on all the transactions that are taking place because it knows it can save that before it loses power completely.
Right. I was wondering about that because another one of the big differences between the specs of these two products is that the enterprise drive from Kingston has significantly higher I/O rates. It can do more transactions per second than the Samsung drive. And of course, that's important in the enterprise because with a server, you're primarily dealing with a lot of typically small transactions that you want to get onto and off the media as quick as possible. Now, another thing I want to ask you is this. This Samsung drive, this 840, has a estimated fail time of 1.5 million hours, which, if I do my math right, I think comes out to something like 175 years or so. The typical SSD has, what, 1 million hours, which is about 114 years. This has a 10 million hour MTBF, which would put it up into the thousands of years. Now, explain to the people who may not have studied storage as a PhD thesis, exactly what does that mean? Do they really mean that this is going to last 1,000 years, or do they just mean that it's 10 times more reliable than a consumer-level SSD?
Okay, here's how mean time between failures work. First of all, they have nothing to do with the number of cycles of the flash memory. So, yes, that enterprise drive will last arguably, on the order of 10 times longer, as claimed, than the consumer grade drive. However, that doesn't necessarily mean it's going to, you can write to it for 100 years or whatnot, or 50 years, or whatever it comes out to, right? The way the failures rates actually work, and before we even get into this, hard disks have a 1 million hour mean time between failure as well. What they do is they take the solid state components, all of them, that are mounted on the board, and they all have different ratings based on the individual components' reliability. And these components can have nothing to do with really electronic devices. They could just be really simple things like resistors or capacitors or inductors. They take all of those specs, they mix them all up into this huge formula, and they go, okay, so in aggregate, here's the average failure rate of this device based on the failure rates of all of the individual parts it's made of. Is basically how it works. Mean time between failures does not account for failure of a firmware. In other words, the software. Right? This is purely a hardware thing. So the enterprise drive has a higher mean time between failure because they have higher grade components installed. It's as simple as that.
One other question is, so I actually have 2 of these drives, and I have to say, when I did the initial testing, I was really blown away. These things are crazy fast. They're much faster than even the SSD I installed last year in some of my servers. And they're much beefier units. I got to thank the guys at Kingston for this, seriously. But I feel more comfortable having that outlandish MTBF in putting this into a RAID 0 stripe. Knowing that they are built to higher spec, knowing that they're using higher memory, higher quality memory pieces, knowing that the controller is built a little bit better. Let me ask you personally, as a system builder, would you feel more comfortable using enterprise drives in a RAID 0, the suicide RAID?
I would, absolutely. Again, realize you should be backing up your primary SSD partition, assuming you're having your operating system on it. Which
I should be, but I'm not gonna. I mean, let's be honest.
Sure. You should do that. It doesn't matter what devices you put into a RAID 0. RAID 0 is, at PC Perspective, we refer to as Death Wish RAID, because, any one failure of anything across the whole board, it just amplifies the effect, right? So, yeah, you're just sort of asking for it. However, performance is much higher, right? Now, you do get some ill effects by running a RAID 0 on solid-state drives, depending on how you set up the stripes. In other words, the data is subdivided in certain kinds of increments, and depending on how whatever the SSD controller is, the hard drive controller that speaks to those individual devices, how it actually does that might increase wear on the solid-state drive. And in other words, give it more wear than it would normally see. And the argument would be, if you were writing a 1 megabyte file to your 2 enterprise grade drives in a RAID 0, if the stripe size was set to 4K, it might subdivide that 1 meg into a bunch of little 4K chunks that would appear random to the solid state drives. In effect, you would get a little bit more wear.
Right. Let me go around the horn really quickly, because I know Curtis and Brian are chomping at the bit here. Let's start with you, Curtis. All right. So let's bottom line this for the IT exec out there. This is significantly more expensive than the consumer drive, but I think what Alan has explained is that there's reasons for that. I mean, it's beefier, it's got better memory, it's got a better controller, it's got a few tricks that allow it to have higher transaction rates. Do you think enterprise people, enterprise managers, understand the advantages of going with this in the desktop, this consumer level in the desktop, and using the enterprise drives inside the servers that are actually driving mission-critical applications?
You know, I do, Padre, and here's why. For most of the people who are looking at doing SSD as part of their enterprise storage, it's still something that's not on automatic. They're having to do their research. They're having to justify it to the C-suite executive committee. It really requires more legwork, more study, and more justification. And all of that makes it more likely that they're going to do the right thing. And, you know, as Alan has put out, I'm sorry, as Alan has stated, you have two different categories of SSD, each of which has a role within the enterprise. And I do think that you're seeing more and more companies who are being very discriminating in which devices they put into which applications. That's a good thing both for the enterprise and for the increased acceptance of SSD in general.
Yeah. Over to you, Chibert. I know that, like me, you're going to be building something with a couple of Kingston SSDs in the very near future. But are you sold on the benefits of enterprise gear? There have been times historically where we've been sold a bill of sale for something that was labeled as enterprise grade that really wasn't any better than what you could buy at the consumer level at Fry's Electronics. But it looks as if Kingston and a couple of other manufacturers have actually done their homework into providing a longer-lasting product specifically designed for enterprise applications. Is that your take?
Yeah, I'm actually quite fond of that whole enterprise grade. So far, I have not been burned. So when I fill up my Ready NAS 4200, basically the Seagate, well, not Seagate, sorry, the Netgear people basically say, you know, we'll play nice as long as you stick enterprise grade drives in there. And I have been running that really continuously for that Linux mirror site and also for the iSCSI NAS on my cluster. And so far, none of the enterprise grade drives have failed. But on some of the lesser NASs that I've been testing, I've actually managed to crash a large number of non-enterprise grade drives in different NASs that actually had better cooling and all that kind of good stuff. I like enterprise grade. I'm more willing to bet an expensive experiment on enterprise grade equipment, especially if it's something like a Sea Glider that's going to be, you know, $250,000 worth of equipment swimming around the Pacific and storing data that's irreplaceable. I'm probably going to put an enterprise grade SSD in there rather than an El Cheapo.
Yeah. You know, I see a lot of people in the chat room. They're having SSD lust, and we can take care of that later on. But first, I want to take just a moment to thank the final sponsor of this episode of Twyat, and that is GoToMeeting with HD Faces by Citrix. Now, good managers know how important face-to-face meetings are in a successful business. Face-to-face meetings are the greatest tools that we have to make sure that our employees, our colleagues, and our clients are all on the same page. And when you communicate, you just do better business. Done properly, projects that normally take weeks, months, years can be, well, decided in just a day or two. That's possible because everyone's on the same page. That's possible because everyone's meeting. That's possible when you use something like GoToMeeting with HD Faces. The modern workforce is spread out, sometimes over great distances. Meetings face-to-face can be time-consuming, expensive, and often plain impossible. But with GoToMeeting with HD Faces, you get to have your entire team there when you need them, wherever you need them, however you need them. That's what HD Faces does for you. Now, here's how it works. You set up your meeting with a few mouse clicks, and everyone receives an email inviting them to the meeting. With a single lightweight client that runs on your Mac or PC, your tablet, or your mobile device, you're in the meeting. With GoToMeeting with HD Faces, you can share the same screen, passing control back and forth to one another, and with the built-in HD video conferencing, online meetings are like being in the same room, with you able to see all the non-verbal communication that is important to doing your thing. Plus, GoToMeeting makes it possible to present your meeting from an iPad for the ultimate in portability. I like having Citrix as a sponsor because I use GoToMeeting on an almost daily basis. My work used to take me to the four corners of the globe on a weekly basis just to keep in touch with my colleagues. That's days, weeks, and months on the road, all while losing my sanity, my health, and the ability to connect with people back at my office in D.C. GoToMeeting not only allowed me to keep in touch with my colleagues in the field without having to actually fly to their location, but I would argue that our communication now is better than it was before because we can meet as often as we need to get our work done. I love GoToMeeting. It's so easy to use, and with HD Faces, I know that you're going to love it too. So here's what I'd like you to do. I want you to try GoToMeeting free for 30 days. That's right, free. Don't wait. For this special offer, visit GoToMeeting.com, click on the Try It Free button, and use the promo code ENTERPRISE. Be sure to use the promo code ENTERPRISE to show them that you're part of the Twiat Riot. GoToMeeting, meeting is believing. And we thank Citrix for their support of This Week in Enterprise Tech. Well, you've done it. You've used up another hour listening to us here at This Week in Enterprise Tech. I want to thank our panelists for coming on and sharing the knowledge, starting with you, Mr. Brian Chi, the Geek in Paradise, who we've been having Skype problems with all episode long. What's going on with you? What's happening in Honolulu? What is the Geek in Paradise involved with?
I've got a really sneaky hunch the UH network is getting attacked again, and that's probably why I'm not getting any Skype love today. But no, I'm actually working on trying to get the ThinLinks clients all upgraded and get ready to send out for some of the first reviews. We've got the RDP version out. The Remote FX version is probably just a couple days away. And the Citrix, with the full DSP integration, is just a few more days past that. So I'm actually getting really excited. I'm going to be able to send out some review units, and there's definitely going to be a review unit heading to you, Padre, and also to Kurt, and we will see about playing with thin clients. I can't wait.
I love it. I love it. Over to you, Curtis. I understand you've got some exciting stuff coming up in the next week for enterprise efficiency. What's going on?
Well, we're going to be getting ready for something really cool because 1 week from today, I'm going to be at Enterprise Connect in Orlando. We'll be spending the first 3 days. I'm going to be live blogging from down there, doing coverage of the conference, of the expo floor. And I understand that there might just be one more member of the Twiat crew who's going to be down there as well. In the meantime, we've got a lot of great articles up. And given the fantastic community that exists here with Twiat, would love it to have any of the Twiat crew come over and take part in the enterprise efficiency community as well. It's a good one. We'd love to see you there.
Alan Malventano, it's always great to have you on the show. You bring such a wealth of knowledge with you from PC perspective. We've seen a couple of your articles in Twiat episodes. What are you doing now? What are you working on? What has people excited over at PC perspective?
Well, all the other reviewers are working on their various expertise devices related there too. I'm working on a Drobo 5D review, which is taking forever because you got to put lots of stuff on it and try to take lots of stuff off and then reformat it and try again.
But that's what we love about you. You're just that thorough.
Bane of my existence, trust me.
Thanks to all the panelists, and also thanks to everyone back at the Twit Brick House who has made this possible, especially my TD, Jason Howell, who you don't know what he goes through behind the scenes. One of these days, when I get my Google glasses, hint to Google, I'll show you what I see, and you can see how hard he works. Also, my super producer, Karsten, who helps to set everything up and make sure that we stay on target and on time. First of all, I also want to ask everyone here to remind people that Twiat is out there. That's right. We want to increase our subscriber base because we think it's an awesome show. We think we're bringing knowledge to the people, and we think that you should tell your friends, your geeks, your fellow nerds in arms all about the Twiat Riot. There's a couple of ways you can do that. The first is to go to our subscription page at twit.tv/Twiat. There you'll be able to find all the different ways to download these episodes to your devices. You want to drop it onto your iPad? Sure. iPhone? Okay. You want to get it on your Android device? You know it. Even on your Zoom. That's right. We give you several different ways to get every episode of goodness dropped into the device of your choice each and every single week. By the way, speaking of each and every single week, did you know that we do this show live? That's right. Every Monday at noon Pacific time. I guess it's not Pacific Standard Time anymore. Whatever it is, noon on the Twitch stream. You can watch us at live.twit.tv. And as long as you're there, why not drop into the chat room at irc.twit.tv, and you'll be able to communicate with me during the show. Every episode, you hear me bringing out points that people in the chat room have brought out. It's a way to meet some wonderfully gifted engineers, some funny people, and some of the greatest trolls in the industry. Also, did you know that Twiat has its own YouTube page? That's right. If you go to youtube.com/Twiat, you can find all of the newer episodes of Twiat and engage with the community. We'll be having a Google Hangout this Friday, and if you join the feed, you'll find out exactly how to get in and how you can have a chit-chat with the good people here at This Week in Enterprise Tech. Also, you can follow me at Twitter, on Twitter, at twitter.com/PadreSJ. Not only will you be able to find out what the Digital Jesuit does in between episodes of Twiat, but you'll be able to comment on past episodes or suggest topics for future episodes. It's kind of an uber geek thing. You got to do it. Finally, please thank Cyberdog in the chat room for handling our notes. He's the guy who goes through our episodes each and every week, pulls out all the good stuff, and makes it accessible to you in an easy-to-understand format. Finally, again, I want to thank everyone who's watching, everyone who comes to play with us, everyone who keeps Twiat going. I'm Father Robert Balacer, and remember, you want to know what's going on in the Enterprise? Just keep Twiat.